Y'all ready?
Yeah.
Again, like I was telling Jacob, I am teaching a 2000 level course to graduating seniors. So while this may seem a little basic, just remember this is a 2000 level course that eventually some sophomore is going to get a hold of and get less than a 50 on their very first attempt. So you're in good hands with Allstate. So anyhow, so most of the calculations are going to be over liming, and then just some basic fertilizer calculations. Again, we got seniors. I trust that y'all are going to do well on this. The purpose of the exercise is so that you get practice. Those numbers change each time that you do the quiz. So when we're talking about, I guess the main thing that needs to be explained is the elemental potassium and phosphorus aspect of the equations. And so many people are kind of might be wondering where you get the elemental composition from. And we get that from what percentage of the overall molecule is actual phosphorus or oxygen. So the molecular weight of phosphorus is 30.97. The molecular weight of oxygen is roughly about 16, but just because I'm one of those analytical scientists, we have to get exact down to the decimal. So when we do our math across, what is this, 60 point, I can't read.
61.94.
Forgot my glasses and my jump drive and my brain. And then for oxygen, we have 79.95. I just got that by multiplying the molecular weight of phosphorus times the number of phosphorus atoms in the molecule. Oxygen, there are 5 in P2O5 times 15.99 gives me the weight. This is in grams per mole. When we add all that up, the molecular weight of P2O5 is 141.89 grams per mole. Of that, 61.94 grams per mole divided by 141.89 grams per mole equals 0.4366. We're going to go ahead and round that up just to make the math easy to 44%. 44% of the P2O5 molecule is actual phosphorus. All that really is. I've been doing these calculations since 2007. They told me instantly that it was about 44%. I believed them, but this is the actual reason why the elemental phosphorus is 44%. It's based on weight of the molecule. So that was for P2O5. We'll do next for potassium, K2O. Is this all coming back, Madison?
Yep.
You
I
gonna-
had the elemental stuff. I don't think I got those wrong. If I did, it wasn't because of this part.
Okay. Potassium is, what is that number on there? It's like 37.9, 39.
39.10.
39.1, that's grams per mole. We have 2 of those. This makes 78.2. Correct?
Correct.
Plus 15.99 is going to be
94.19.
94.19 grams per mole. 78.20. Or 83%. Everyone seeing how we got that? It's just a percentage of the overall molecule. Great thing about video is it can be stopped. I know I got you on your homework. Now read the question. I will be posting these online, but let's see if I can't get this so that you can see it.
Back up a little bit. There you go.
All right, so the question is, for your 1 acre yard, soil test recommends applying 74 pounds K2O, 1 acre. There are 0.24 pounds of K2O in 1 pound of 12-16-24. The question is actually asking you how much elemental P was applied. But first what we have to do is figure out how much K2O or how much fertilizer we actually applied so that we can get back to how much elemental P was applied. So 74 divided by 0.24 is 308 point, oop. Of 12-16-24 fertilizer in our 1 acre yard. There are 0.16 pounds of P2O5 in 1 pound of 12-16-24.
There's a typo on that.
Where?
In case you want to change it, right
Oh, it's
there.
14. Yeah, okay, I will. All right, and of that, 0.44 pounds of P in 1 pound P2O5. So the beauty is that cancels, that pounds P2O5 cancels, and we are left with pounds of P per acre. When you do the math out, it comes out to 21.76 pounds of elemental P per acre. That's the reason why I teach it this way. Because once you teach it this way, you can't mess it up. It's just math. It's just multiplication or division. Now, there are some students in my 2000 level class that haven't done this math yet, that are still cross multiplying and dividing in the wrong places. But once you get it set up like this, it's stoichiometry, and it's unit cancellation and multiplication. Everyone good there? I'll see if I can't pull this up because I know where you're.
I feel like I was setting them up right. I just, like, I wasn't doing it on paper, so if I did mess up, I don't know where it was. I wouldn't have been able to catch it.
Exactly. This thing's gonna take forever. Well, what do y'all pull up? I guess it doesn't matter. All right. So the good thing about the math assignment is that those numbers change, but the equation is still the same. And so I think what might have been messing you up is that we applied an amount of product over a certain area.
Mhm.
And you might not have divided by the area because I asked for it in pounds per acre.
Yeah.
So let's say the problem says you needed to apply 1,874 pounds of whatever material this 18, 16, 24 fertilizer over 5 acres. And I might ask for how much elemental K was applied per acre. And so that is going to be, there are 0.24 pounds of K2O in 1 pound of 18, 16, 24. And we know that there are 0.83 pounds of elemental K in 1 pound of K2O. And so if we were to do the math all the way across, someone got a calculator, can do 1874 times 0.24 times 0.83.
3.73. What you got?
3.73.
Oh, I put a decimal.
3.73.3008. 373.308. That's what I said.
373.08 pounds of K over 5 acres. How much per acre?
That is what I did.
Ding.
Because I think I solved for the 5. Like I think I solved for 1 and then gave you 5 rather than solving for 5 and making it.
Correct. What was the answer?
74.6.
74.6. Do 1874 divided by 5.
374.8.
What's not adding up here? It is. Okay. All right. Did it still come out to 74.6? When you did this math, 374.8 times 0.24 times 0.83,
74.6. Yep.
74.6. There's 2 ways to solve just about every problem. The primary purpose of that is to get you to see that it was for 5 acres. And that was also something else that I noticed on the homework assignment. There was only one person who got the correct answer for the for the lime calculation. I'll go over that after, as soon as Jacob's finished writing that down.
You're talking about the Word document that, like, we sent back to you, the one that was due
Yeah.
on Monday?
Mhm. You got it?
Yep.
So in that final problem, the soil test recommended 2.75 tons of lime of 100% calcium carbonate material. And 2.75 tons times 2,000 pounds in 1 ton is equal to 5,500 pounds of calcium carbonate material. And then the 55,000 pounds or 5,500 pounds of calcium carbonate material in 1 acre, and it was times, there are 1.025 pounds of calcium carbonate and 1 pound of co-op material. Whatever that math is, it came out to be like 5,355 or something. Everyone set it up right. It's
Right.
just they did it for 2,000 pounds instead of 2.75 tons.
Right.
Like, so the math is correct. We're just reading over the question very quickly and assuming that it's just for 1 pound.
Right.
Like, so I got the math down home. It's trying to be able to read the problem and then assessing on whether or not you're putting out the right number. Is that the right value for it? You know, like you said, you gave it to me for 1 acre,
Right.
but it was really over 5 acres. What am I doing here? And so that's that critical thinking, deductive reasoning, like, hey, wait a minute, I put out way too much
Right.
P2O5 on this, but you wouldn't know until after you worked all the way out and then had to go all the way back.
Now, are these quiz questions, are they gonna be a logical amount, or is this like a computer-generated amount of numbers?
No, it's going to be a logical amount.
Okay,
Like, so I get to set that up.
okay,
I get to set the range.
okay. I was just
Of,
making sure.
right, no, I wouldn't have made it just this astronomical. I'm not about testing your math anymore.
Yeah,
I know you can do the math.
right.
Can you pay attention to the problem and get the right question out? So, like, I guess for me, that's level 2.
Mhm.
This is math. This is just basic
Right,
multiplication. This is middle school stuff. Once you set the problem up correctly, did you set the problem up correctly though?
right,
So that's why I went back over and did that. It was 1874 over 5 acres. If you multiply all the way across, you'll come up with that equation that was 1874. What did that end up being, like 374.8 or whatever, 374.08 pounds K over 5 acres. Whatever that number came up to be. Right? So there's not much to this.
Mhm.
Again, y'all are seniors, so now it's like, hold on, how much do I really need over this? You know, and then I guess maybe later on when we do fertilizer calculations again, it'll be, well, we're starting to make those blends. I didn't get to do that. Are you in Fenewald's forages class? He had me teach fertilizer calculations and forages, and I wasn't able to get to making the blend yet. But y'all are all seniors and you're all right here. So when we go to calculate the blend, it won't be that difficult. I mean, I think that's pretty much it.
Can we do one of these?
You
It's
want to?
just- It just feels work.
What is it?
So the producer applied 144 pounds. Of an 18,912.
What is it, an 18?
18,912 to 4-acre field.
So 18, 9, 12.
How much elemental P was applied per acre?
What goes next? When I'm right here. Tell me how I should put my,
Put your 0.09 pounds of P2O5 on top. For every 1 pound of 18,912. And then your elemental P,
and that is,
0.44 pounds of P.
we'll just call that LP, in 1 pound of P2O5.
Right.
Let's do this across the top first. Do the math across the top for me.
Yeah,
Just the top part.
It's 5.7.
144 times 0.9 times 0.44.
144 times 0.09 times 0.44. 5.70.
And this is pounds of P over 4 acres.
And then divide it by 4.
Correct.
It just felt like 1.43 pounds of elemental P per acre. That just seemed low. But that's how both of my answers came out, and so I thought I was missing something.
It's actually not really that low.
Is it not? Okay.
Not really.
Okay.
Because I mean, you got to figure,
I'm just
so.
used to a lot bigger numbers.
Huh?
I just feel like I'm used to bigger numbers in this class. So that
Try and
just
find one.
felt-
Scroll down and do the K2O.
I did. I started with the K2O. And
Well, give me a problem so that I can look at it.
730 pounds,
Of what kind of fertilizer?
21, 10, 23. 5 acres.
What about my top number?
$139.36. Okay, I did that one wrong. The answer's 27.87. I must have just missed something in the calculator. Cause I got 2.79. So my decimal place is just in the wrong place. See, that one's not low, so that would have really thrown me off for the other one. Because I went from kind of low. Like, that just seems more legitimate to me.
All right, well,
I just like that number better.
let's check this out.
Solid line.
I do that though. You can ask him, I'll write on the test and be like, this doesn't seem right.
All right, do 730 times 0.23.
167.9.
A soil test recommends applying 168 pounds of K2O per acre. Right, let's just go ahead and round that up. We'll make that 168.9 pounds of that's a common rate. Okay, let's do this up here. Do 144 times 0.9. That's actually going to be like 14.
144 times
0.09.
12.96.
So 12.96. Now let's just make that 13. A soil test recommends applying 13 pounds of P2O5 per acre. Right? So applying a lot of P, we typically don't apply a lot of phosphorus because
Okay.
P is immobile, right? So it's
Right.
there.
Okay.
When you go to do the soil test, it's already there.
Right.
So your P recommendation is going to be low.
Okay.
Your K2O is mobile, the plant is taking that up in high quantities, and therefore you're removing that much from the soil. So your K2O levels, your recommendation, you have to replace more of that.
Okay.
That's also why you see that your K2O is double as 60.
Mm-hmm.
Because if not, we'd be applying astronomical numbers. So
Right.
think about as you get through what I'm asking in each one of these. And so now we have 13 pounds of P2O5. And 1 acre times 0.44 pounds P and 1 pound P2O5. Right? Okay, how about this? What if we had, think about this now, what if we had the soil test recommends, or let's say you want to apply 100 pounds of N per acre, and you used an 1846O. And so there are 0.18 pounds of N and 1 pound of 1846O. That is going to equal 100 divided by 0.18.
555.56.
So you need 556 pounds of 1846O. 556 pounds 1846O times 0.46 pounds P2O5 and 1 pound. What's that equal? It's for like 225 or something.
255.7.
255, all right. So 255.7 pounds of P2O5. Astronomical.
Right. That makes more sense.
Does that make more sense
Yeah.
now?
Yeah.
It's all on how much the plant uses.
Right.
The plant doesn't take up very much P2O5 because it's immobile in the soil.
Right.
It can't get to it. Remember, this is me going all the way back to the broom,
Right.
and that the P2O5 is,
Right.
it moves by diffusion, but very minimal. So
Right.
the plant didn't take it up. It's still in the soil. So your P recommendations are going to be much lower than your K2O recommendations.
Okay.
Should be anyhow.
Right. Okay.
Cool?
Yep. Cool.
Makes sense?
Yep.
Any other questions?
This is probably a stupid question, but with the like elemental K, that 0.83 to 83%, is that a constant?
Yeah, so it is a constant because of the molecule is K2O. It's always K2O.
Okay.
But so right, so it's a constant. It's not going to change because it's chemistry and it's
Right.
percentage of that molecule. But the thing is that I know it's 83%. That's what they told me when I came up, and I just said, oh, you know what? I'm just going to trust that it's a constant. But students go, where'd you get 83% from? Why is it 83%? Which is a good question, which is perfectly fine to ask. Why is it 43%? Or why is P always 44%? Well, it's because where'd you get the 44 from?
Mhm.
So now we're having to trust that I'm telling you the truth. When I do the math, you can then see.
Yeah.
When I did it in fertility, they all went, oh, that's what Earhart was talking about. That's where